What I want to look at today about graphing these is that there's a very simplistic thing to do. And we are going to talk about rough sketches again. But we are also going to look back at some of the vocabulary we talked about in this chapter earlier. We're going to revisit local maximum, local minimum, and end behavior. Remember, end behavior is what's happening at the tails of the graph. So in this case here, whenever we're looking at graphing polynomials, what we always want to do is plot zeros. Now, for what we're going to be doing, the polynomials themselves are going to be already factored for the most part for you. So you're not going to have to factor a 4-term polynomial to get all the way to your zeros. It'll be written in such a manner that you'll be able to find your zeros relatively easily. In this case here, could you tell me my two zeros?
2 and -4.
2 and -4, good. So if my two zeros are at 2 and -4, what will the degree of my polynomial be? It's going to be 2. So I know right away, since there's 2 zeros, it's going to be a second degree. What does every second degree polynomial's graph look like? A parabola. It's either going to be up like a cup or down like a frown. Do you remember how to tell the difference? The A value. The A value. Now, this polynomial, if you remember from last chapter, is written in that intercept form where your A value here is 1. So that means this one's going to be up like a cup. So, it's going to do that somewhere, right? Here's the new term for you. How many changes of direction does this graph have? 1. There's 1 change of direction. In this case, it changes direction where?
At the vertex.
At the vertex. The vertex of this graph is called the good. It changes direction at its minimum. All right? The rule will be the number of change of direction is always equal to the degree minus 1. So if you have a 5th degree polynomial, you have 4 changes of direction. If you have a 7th degree polynomial, you have 6 degrees. Okay? The graphs that we're going to be looking at will all have real solutions. We're not doing anything with imaginaries, so it's just going to work out nice and clean. All right? Let's look at another example. Again, we have f of x is 1/4 times the quantity x plus 2, and then x minus 1 quantity squared. And I'm going to do a rough sketch of this. And whenever I'm rough sketching, I always start by plotting my zeros. Where are your zeros? -2. I have a 0 at -2. And what's my 0 for the other one? 1. Is that 1 repeated? It is. And why is it repeated? Because it's squared. I'm glad you asked. No. Think about this. This is junk squared, right? Junk squared means junk times junk. Oops. And you're right, so you have x minus 1 and x minus 1, so your zeros are at 1 and 1. Why do you have a 0 at the same spot? Well, think about the rules of quadratics. Remember when we talked about the discriminant? If your discriminant was equal to 0, you had one real answer. It was on the x-axis. This means that you have the parabola is either going to be coming from this direction here, or the parabola could be coming from this direction here with another 0 out here.
Also changes direction.
Exactly, because what's the degree then of this function? It's third degree. I'm going to have a squared term in an x, which gives me a third degree polynomial, which means I'm going to have 2 changes of direction. So what occurs then, depending upon the a value, I have a 0 at 1, and I have a 0 at -2. Yeah, Gail? X, and then I have a squared term here, so it's going to be x cubed. If you FOILed that all out, you get x cubed. Plus, if you notice, you have 3 zeros, which means you have a third degree. Okay? So now let's think about it in terms of the a value. What's the value of a? Is that positive or negative? So if something is positive and you're reading it from going from left to right, if a is positive, what do you think the graph is doing? Increasing or decreasing? Increasing. Upcreasing. I'm glad we're making up vocabulary words. Here's what happens. It is increasing because the a is positive. Through that, then that means it has to change direction to stop here. Since that's the next 0 and it's repeated, it has to go back up. So you have 2 changes of direction for a third degree polynomial. Yeah. Okay. The a value is positive. It's a third degree polynomial, which means it's going to change direction twice. So as I'm reading from left to right, it's increasing. After I pass through this point, that means somewhere around here I'm just going to change direction. I don't know where. I'm just going to know I'm going to have to change direction to go back to here. Once I get here, it's got to change direction and go up. That's all I'm doing. I'm just rough sketching it. It may look like that. This might go way up high and then come back down and go back up. It might be a little bit flatter. Exactly.
I did it with my calculator and it looks flat.
It will because it's a rough sketch.
No, I mean like it's like not even.
Did you put it in wrong?
Maybe
Yeah,
Mr.
she's not.
Murphy's never wrong.
I'm never wrong, right?
Wait, so if the A is negative, is it going to be going?
Yeah, if for the third degree you want to be going the other direction, change and go like that.
Oh yeah.
All right? Yeah.
What? Wait, so isn't there a way to like find the vertexes like this too?
Yes, and that's where these things come into play.
So that's how you know.
This value would be called the local maximum. Because you have a maximum and a minimum in this problem, this would be the local maximum, and this would be the local minimum. Yeah.
What if you have like more than 2 changes?
Then you're looking at within specific boundaries. You can have multiple maximums and minimums depending upon what section of the graph you're looking at. Yeah.
I still don't understand why you got 1 and 1, as your x, where it's crossing through x, you got it twice.
If you have the graph, let's say the parabola y equals x squared minus 4x plus 4. If I go to graph that the old-fashioned way, opposite of b divided by opposite of b over 2a, so it's 2 times 1. All right, that gives me my axis of symmetry, correct? So that's at 2. I substitute that in, and I get 2 squared minus 4 times 2 plus 4. So it's 4 minus 8 plus 4, which is 0. So that means that my vertex is at 2, 0. This A value is positive, which means it's up like a cup, so it's doing that. It only touches the x-axis at one spot. There's only one 0 for that. If I set this equal to 0 and factor it, you get x minus 2 quantities squared. Set it equal to 0, so you have x minus 2 is 0, so you only have one 0 for that parabola. What happens is if you've got a squared term within that whole string of things, it's just telling you that the curve is going to touch the x-axis at one spot. If you have 3 terms, you're going to have 1, 2, 3 different zeros where it's going up and around them. It just so happened that this is shifted to a spot that's going to touch it in one space. Is that clear?
Yeah.
Let's look at another one. Very similar to that. Very similar. And this one I have f of x is negative 2 times the quantity x squared minus 9. Yes.
Are we gonna like draw a graph?
We're not
Like
getting-
in vertex form, or are we gonna have to like how?
It's going to be just like this. There's not multiple forms we're talking about polynomials, and I'm going to show you guys how to write equations in a minute here, and you're going to see that it's really straightforward. There's not a lot of scariness here. Again, what was that? There's 3 zeros. Where are they located? Negative 4. I have a 0 at negative 4. Good.
Plus or minus 3.
Good. That took a lot for you to say. I appreciate it. Do you guys all see that in this case here you had to factor x squared minus 9? That's about as complex as the factor you have to worry about. It's not junk squared, it's the difference of 2 squares. It's a little bit different. So you have 3 zeros at 1, 2, 3, negative 4, and positive 3. Again, what's your A value? It's negative. You have 3 zeros, so how many changes of direction should you have? 2 of them. So if my A value is negative, looking from left to right, is this going to be increasing or decreasing? Decreasing. So it's decreasing to here, and then what's it have to do once it passes that 0? It's got to go back up, and then what's it going to have to do? Go back down.
So you don't even care about the line.
Nope.
Connect the dots.
Yep.
Wait, is this all we have to do in the test?
Yep.
Yeah, so it's just us.
You have to be able to plot your graphs. I might ask you what's the local maximum, what's the local minimum, but in order to do that, you have to use your calculator. So if I'm asking you to do this rough sketch-wise, I think that's a better tale of can you do that, because can you identify zeros so you know if it's which direction is it going. That's all you got to be able to know for right now.
So wait, if you're asking for like local minimum,
You press buttons in your calculator because those will not be easily found values. Your calculator, you know how you've got a maximum and a minimum button? You'd be finding them within those boundaries, and it'll do the work for you. All right, it's nothing. It really isn't anything at all to do that. I think you're right.
So you won't need us to find the max and minimum on these?
No, I told you to use your calculator. But if you're doing rough sketch, don't worry about it. Yeah.
Does it do you pretty much just polynomial or whatever you call it, where it like doesn't pass the x-axis and it like just somewhere off in space up here?
You could, but I'm going to give you stuff that has zeros. I'm going to give you stuff that has zeros. Okay? But you're right. You can have that occur, but I'm not going to do that to you. I just want you guys to go plot with zeros. You'll worry about that next year. Speaking of which, let's do the other part of this. This is the 6.9 stuff. We're going to write enough. I'm going to give you ordered pairs, or I'm going to give you the graph. You have to write the equation. But all you have to be able to do is we're going to write it out in that, I don't know if you want to call it that intercept style. We don't have to foil any of this stuff out. We can just write it out in terms of zeros. Yeah.
So it's like what we did in our homework class.
Similar, very similar. Do you remember what the last chapter looked like when you had to write out the equation, the parabola with vertex form?
Yeah.
You had y, not vertex, intercept form was a, then you had x plus an h, x plus a k, or x minus h, x minus, things like that, or p's and q's, or whatever they were. The only thing that changes now is that we're writing about a cubic. How many zeros am I going to have? So it's going to be x. If I look at my graph, I have zeros at -3, +2, and +5. And all this whole chapter, if I was asking you guys if I have a 0 at -3, what will my term be? Good. If my 0 is at 2, what's my term? If my 0 is at 5, what's my term? Do you see why I have been asking you guys that this entire chapter?
So that's how
Get
I
you ready for that.
So
Yeah.
fill in the graph, right, from
You'll have a graph, or you'll be given ordered pairs. I'm going to show you one example of both. The graph will be labeled. All right, the graph. Ah, there's another point there. You still got to find an A, don't you?
So then you
No.
just choose one of the zeros and make y
zero.
zero.
Not really.
See that down there? That's an ordered pair, isn't it?
Yeah.
Isn't that an X and a Y?
Yeah.
Substitute in. So for Y, you substitute in -15. For X, you substitute in 0. And now comes the tough part. 0 plus 3.
-3.
0 minus 2. 0 minus 5. What's -2 times -5?
10.
What's 10 times 3?
30.
-15 is 30A. Bless you. And what is your value of A? -half. Good. Now, what do you think you're going to have to do with that? Substitute where? In for A. So basically, all you're doing is you're going to substitute this value for A into that original string that you put together. And it would look like y equals -1/2 x plus 3, x minus 2, x minus 5, and you're done. Don't do anything else. Don't need to multiply out. It does not matter. That's all you have to do. You identified your A value. I know where the zeros are. Life is hunky-dory.
In Spanish, though, so it would be the messed up the childhood.
Let me show you what this looks like when you have ordered pairs. The only thing that's different is that there's no graph. You all right? So if I give you 4 ordered pairs, you have to figure out which one of those are zeros and which one of those is the extra set of ordered pairs. So one of these things is not like the other. One of these things are different.
Oh, isn't it like you threw out a picture of...
Just stop. I'm so sorry. That was just me. Which one of those is not an ordered pair of a 0? -1, or excuse me, 1 and -3. Good. So as I go through the problem, again, we start with y equals a times, well, if -1 is my 0, what's the term? That'd be x plus 2, and then the other one would just be x. What do I substitute in for x and y? 1 and -3. Again, the tough math. 1 plus 1. Gotta go slow, gotta go slow. 1 plus 1 is 2. 1 plus 2 is? So 2 times 3 times 1 is? -3 is 6a. What's your value of a? Hey, don't think that it's always going to be -1/2. It's just dumb luck.
I really hope the test.
I hope so too. That would be funny. And then again, where am I going to put that -1/2 whenever you're right? Put that in there and you'd call it a day. And that's all you got to do, guys. Okay?
So does that mean no homework?
So you just have our homework now.
I'm going to give you the homework right now.
Okay.
In section 6.9, it's on page, I forgot.
That's
okay. Let it load up.
Oh my goodness, it's 1, 1, 2, 2, 1, 3. That's the date.
It'd be better if it was 1, 1, 2, 3, 4.
That's not possible. Yeah, Dylan.
How is it not possible with 1, 1, 2, 2, 3, 3? Really?
How is that possible?
20 years from now?
Oh, that's right.
Wow, math is tough.
No, I thought it was 33.
It's not like
Day of the month.
See what I'm dealing
It
with?
is 20 years.
Do you guys have any
Oh, that is.
sorrow for me sometimes?
Unless they change the calendar, it should
I'm
still
deaf,
have.
but I wasn't wrong.
I'm giving you guys 2 problems. 2 whopping problems out of section 6.9 where you had to write out the equation. The 6.8 stuff will be incorporated into the chapter review problems that I'm giving you. The chapter review problems are, they're right out of the book. The link works on the website. I changed it so it worked. I realized it was coming up as a bad file. It was. I fixed it today. It's now a PDF file. Before it was coming as a doc file and it wasn't working.
It's not blurry anymore?
No, it's not. It should be a PDF and it should be okay. Should be. Sweet. Let's get better glasses.
Triple super check.
Again, get all these done for Monday. We will go over the chapter review together to prep out for the test. Come with any extra questions on Monday and we'll go from there. Yes, sir.
Since the sampling class.
Yeah, it's the same.
What's that?
The first problem is the same problem as the
Don't tell anybody.
Okay.